you'll have to forgive me. I do not have a screen recording program currently on this computer. So I'm going to be showing you, I just have the camera zoomed in on the screen, and it's not going to be 100% perfect. I hope you're able to see my mouse as it moves around, but I'll be kind of pointing things out with my fingers as well. So this is the house that I have designed for our family. This is a very rudimentary, quick massing setup for the home. I'm going to show you the plan in a minute, but I just wanted to give you an idea of the simplicity of the home and talk about a few features of the home. So this is, you can probably surmise, is the south-facing facade of the home. What I've got here, and I'm going to actually turn this off for a minute. I can't turn everything off really easily, and I should have grouped those together, and I can do that really quick. There we are. So as you can see, like I said, this is very rudimentary, but this is the main idea. So the house is slab on grade. It's a raised slab, and it's going to be an insulated slab, and that's going to help with transmission of temperature through the floor. The house is a double stud wall. It is a pole barn type construction. You cannot see it on the side here, but this is effectively your standard metal siding for that type of structure, and this is a corrugated metal roof. The roofing material and siding material are going to be of a white and or silver color. In this case, I did a silver roof and a white home in itself. What that's going to do for us is reflect sun back off of the house, so that we're not absorbing any extra heat into the home in places that we don't want it. You can see the solar panels right here on the roof, and this is just a rough calculation of how many I'll need, but obviously the roof or roofs can take more panels up there if necessary. That's a standard size panel. I believe it's 3.5 feet by, or 4 feet by 2.5 feet. I'm sorry, I cannot recall how big they are, but you can see most of our large openings, these are 3 foot by 6 foot tall windows, are going to be on the south side of the home. There's a reason for that, and I'll talk about that in the plan a little bit. This porch roof here could disappear as well, depending on if we need the solar gain through this window, which is a bedroom window here. On the east side of the home, there is only a door, and on the west side of the home we do have one window and one door, and what that does is help keep the heat gain down on both sides of the house. It helps keep it down considerably. On the north side of the house, which can typically be a windier side of the house in the northern hemisphere, you don't want very many windows at all. These windows are simply here for egress and some light, obviously, into the rooms, but they are more for fire code and escaping out of the bedrooms. You have to have a certain size window for that, and this is a window into a bathroom. But let me go ahead, let me actually describe and show the other items that were on there. This is a greenhouse. See, sorry, I was experimenting with a roof over here. This is a greenhouse. Will act as a thermal break on the south side of the house while still allowing light penetration in through the windows on the house to heat a poured concrete floor. And this is a clear triple wall polycarbonate used commonly for flat sides in a greenhouse type situation. This is very simple construction. You can see that light will penetrate straight through those windows. And we've also got our roof overhang calculated for the summer sun angle, so that we're not getting any sun in the summertime down into the house itself. Sorry, this is 7 a.m. We'll go to one of the hottest parts of the day. We'll go around 1 o'clock in the afternoon. So you can see the sun penetration into the house is very, very, very minimal. I can actually extend this overhang out a touch more if we want to completely cut off that sun heating up this interior space in the summertime. But during the wintertime, we'll go. This is January. That was January 25th. We'll go to the wintertime. All right, here we are in December. And this is again rudimentary. This isn't perfectly calculated for any particular latitude, but it is in the northern hemisphere. You'll see the sun penetration into the house in the middle of winter is great. What this is going to do is help reduce our heating costs in the wintertime and help reduce our cooling costs in the summertime and help reduce cooling loads. How much stress and strain is put on any type of cooling system. Now, it is our goal to not have any cooling system for this home, and we are still working out the energy calculations to see if we can pull that off. If there is any cooling that'll be needed, it'll be very, very minimal. So let's go to one of the plans here. Let's go to the plan of this home in particular. Alright, so you can see the greenhouse out here. You can see the greenhouse out in this space. It's fairly deep, 10 feet, which will give you a good amount of space to grow your winter greens and winter crops. It does have direct access to the house. It will be heated in the wintertime by geothermal means, and we are going to install that ourselves. Very simply, I'll show you how to do that project in the summer. It's just geothermal air movement as we dig down some trenches underneath the greenhouse itself. As you can see, so you come around from the kitchen. It's very close to the kitchen. So here's the kitchen sink. Come through the mudroom and the laundry, and you're out in your greenhouse, picking your greens, bringing them back in for lunch or dinner whenever you eat your greens. This house was designed to be very minimal but still be useful for our family. This house is 1,440 square feet, not including the exterior porches or the greenhouse. So the interior space, what we call AC space, air conditioned space, is 1,440 square feet. That could actually be calculated a little bit less because this double wall construction on the exterior does eat into that, and it brings the house in a little bit, so you could call that less square footage. Let's zoom in on that feature. This is a double stud wall exterior, and let me show you a couple images of why we're going to do that. What that does is help us get an incredible amount of insulation on the exterior depending on how thick you build that wall. Ours is set at 8 feet, or 8 inches, sorry. 8 inches, which allows us an exterior 2x4 construction and interior 2x4 construction with a 1-inch gap between. What we're going to do is we are going to stagger the studs so there is no thermal transfer between the exterior and the interior. So cold can really easily transfer through the 2x4 and into the interior of the house. So in a traditional stick-built or wood frame house, your drywall here on the inside or your gypsum board will be right on the other side of this stud, and it allows cold to come through. And wood doesn't have a very high R value at all. It's better than steel, but the cold will still transfer right through that and into your house. What this does is gives the insulation the proper amount of space to really work and be efficient. And the studs aren't touching one another, so there's no thermal transfer between the two. It's a very, very efficient way to do it. And you can skin the building however you want with whatever type of siding. In this case, it's wood siding with built-up furring strips. But let's go back to the plan. It's very simple. It works very well. It's 3 bedrooms, as I say. And another feature of the home here is this concrete block wall. This concrete block wall is grouted in between. That means there's concrete poured in between the concrete block holes. What that does is when we set a wood stove directly in front of it, it acts as a heat sink. That wall in the wintertime is going to soak up all the heat from that wood stove. So if you're not up to tend to your stove and feed the fire in the middle of the night, that's okay, because this wall is going to hold a lot of heat and it's going to radiate off during the middle of the night. So that is also the idea behind the concrete floor. So in the wintertime, that sun is going to come through here and it's going to heat up this concrete floor. Now, yes, you can do tile. I don't think it stores the heat quite as well as the raw concrete. However, I don't think there is a huge difference. So in the wintertime, that sun's going to heat up this concrete. At nighttime, it's going to, when the sun is down, it's going to radiate out the heat and help to heat the home. That is very, very, very energy efficient means of doing sustainable homes. You can also make this island top here poured concrete. That will give you an extra heat sink in the middle of the winter time. So as you can see, 3 bedrooms, fairly nice size. You know, the master's 13 by 11.6. That's not luxury suburban mansion, but that is quiet country homes. The master bathroom is generous, and that actually can be pared down some. The west porch here is extended a little bit beyond, but we're probably going to pull that back to be a perfect rectangle. So this house may need a bit of modification. The simplest way and the cheapest way to build is a rectangle. We've somewhat accomplished that, and we are working with some builders to see if they can pull it off for us with a metal structure, a pole barn type structure. And set those posts at the corners out here. We haven't fully committed to the pole barn style of construction, so I just want to mention that we are still weighing costs back and forth between the traditional frame built and the pole barn built style. If we do the pole barn built style, those timbers can be 8 inches or so in depth, and we may need to, some are mostly 6, but some are 8. I don't know what, we'd have to get the engineering done to see what this house would require. If it's 6, I'm going to actually assume it's 6, that will not cause a thermal transfer from the exterior, because we will stagger our studs on the interior to not obviously touch that. That will come in to the space considerably, but there will still be some insulation between the pole barn column and the interior wall. We should be able to get between an R38 and 40 on the exterior walls with blown in cellulose insulation. And let me show you what we're going to do with the roof here. So this is called a raised heel right here. Most of the heat loss in your house is going to be when your wall connects to your ceiling, and this roof piece in a normal traditional construction is down on top of this top plate. This is the top plate of the wall right here. So when you have this roof rafter down on that top plate, your insulation cannot extend all the way over the exterior wall here. What that does is that causes this corner, the upper corner in your house, to lose a tremendous amount of heat. The ceiling, where your wall and ceiling meet right here, loses a tremendous amount of heat. What this raised heel does, and you can do this in a truss or traditional, just framed out, wood framed out, you just do what's called a pony wall on top of it. It allows you to extend this insulation bed completely over the exterior wall, so you're not losing all that heat right in that corner. You have the same amount of R value, and it still is able to breathe, as you can see indicated by this blue ventilation, this blue arrow here. Also, what we will be doing is adding an additional, and this doesn't show it, but an additional radiant barrier that lays on top of the insulation. It's a foil material that's perforated. It lets moisture through, but it reflects the heat. As the heat comes through your roof, it bounces right back out again. That keeps your inside much cooler as well. So there's many strategies we're going to be adding to this home. Let me go and show you. Well, this is a quick picture of an insulated slab in a pole barn style construction. And let me show you again what that looks like in the diagram here on a slab construction. And this doesn't show a double stud exterior wall. This is just for showing the insulated slab partially. So this exterior can be insulated as well, which is going to help with keeping the inside here in the corner from transferring too much heat or coldness through this footing and foundation wall. What we have here is two separate. We have your concrete slab floor poured independently of your foundation walls. You've got a drainage bed here of gravel, and then you have your typical foam board insulation right here. So you're insulating that that concrete slab from the cold from underneath. Let me see if I can find that other diagram that I wanted to show y'all. This is a little bit different kind of construction, but it gets the point across nonetheless. You can see the exterior of the slab is also insulated in this case, as well as that interior. It's poured as it's not monolithic. It's poured as an independent piece apart from the foundation wall. This is another way of doing it, a little less energy efficient, but not too bad if you're going to do metal type of construction with metal studs. That might be not as cost effective as some of the other strategies. However, in this case, we have, sorry if you can't see it, it's right at the bottom of the camera here. This is a very, very insulated slab, fully insulated slab that is monolithic. So the slab floor here in this basement construction is poured along with what's called a grade beam, which is the structure, the foundation structure for the exterior of the wall. This does have a double or a high heel or a raised heel truss on it, and a double stud exterior wall. It has this is a basement type of construction, but you can see they did it with a foundation here, and or a basement in this case, partially buried. In this case, it's just slab on grade. I'll put all these at the end of the video so you can see them as well. So let's go to my buddy's house that I designed for him, and we're going to take a peek at Philip's house. Philip is building a house in Arkansas. He has a limited budget as well, and he needed 3 bedrooms, but a little bit more space above. This house is 1,800 square feet, and it's 3 bedrooms. He's got a large great room, I guess you could say, through the center here. He's going to be employing some of the same strategies as we are. This is one of his earlier plans. He's actually pared this back a bit, so let's go take a look at that. Here's the new one that I did for Phil, and in this case, he's pulled this back, this bump out that was at the front of the house with the entry point at the front. He's pulled that back because we discussed the strategy of the shape of the house, and that a rectangle shape or square shape is going to be much cheaper way to build a home. So he pulled that back and eliminated his front entrance, because his garage is going to be placed off here to the side, and he's going to have people coming in the side of his home here anyway through the laundry room. Since it's a country home, you really don't need a formal entry. You can design that in, but it's going to eat up space, of course. So we can go from here, we can go up, or we can go here and go down. Every home plan is designed specifically for the user. Everyone is effectively a prototype, and it is hinged upon how the client likes to live. So my friend Phil wanted a separate master suite aside from his kid's bedroom, separated by the majority of the function of the home in the center. Some people like to be near their kids, some people like a formal entry, some people like certain other things, but this is very customized to Philip and his family. So I hope this helps all of you get a feel for, apologies, oh that's mine, get a feel for what we do and how we can employ good energy efficient strategies for the home, and how that home lays out for your family. Every family is different. Every place is different too. This one has a great amount of slope. This is in Arkansas. This has a great amount of slope next to the house. It's got a walkout covered porch or deck up here, and as you can see, this house has a basement, so it does have a set of stairs, and he will have a lot of space below. But here in Texas, with our home, the easiest way for us to do it is in the cheaper way for us to do it. The more economical way is for us to do it slab on grade. and connect that greenhouse to it. We actually did try to modify this plan for Phil's needs on Phil's property, and it just didn't work. So it's highly specialized as to what we can do on each property and for each client. And yeah, so I hope you enjoyed the video. Please leave comments for me if you have questions about any of the other technology we're going to be employing into the homes, and I will continue to post ideas for building strategies. They may be Texas focused, but we can easily communicate with one another to ask questions about strategies for other parts of the country, other hemispheres. Obviously, if you live in South America, you'd be orienting the house in the other direction. North would be up this way instead of down this way in this particular drawing. And I actually looked down at my calculations. I did bring the AC space in, so this house is actually 1,407 square feet, not 1,440. 1440 is through the exterior. Anyway, if you like our videos, please give us a thumbs up. Please subscribe to our channel. We'll be posting regular content about our move to the country, our expertise in building and designing, and we'd love to hear from you guys. Take care. Have a blessed day.